Hi, I'm Eric Kang, a Senior Program Manager in Database Systems Group. In this video, I'm going to show you how SQL Server 2017, Docker Container, and Container Platform worked together to enable Agile DevOps practice. In this session, we'll quickly go over the benefit of running SQL Server 2017 in a Docker container and Container Platform. Then, we will work through quick tutorials for the basics, building your own Docker images, deploying SQL Server 2017 to a container platform, then automate the process. First, what is the benefit of using container? Container technology like Docker is gaining a huge popularity nowadays. The reason is, it is fast to deploy a simple or complex app and database environment. It is portable and predictable. It effectively solves the issue of it works fine on my PC while the app and database is failing in production and in customer's machine. With a container, you can take the advantage of a container platform like a Kubernetes, DCOS, Docker Swarm, and Azure Container Service. You can maximize the resource utilization of your computing resources, and also you can automate the management of container deployment, scheduling, health, and its resiliency. The command line interfaces and APIs are well defined, so you can automate not only application and database, but also the whole runtime environment. Let's start with the basic commands to run SQL Server 2017 in a Docker container. Just to remember, Docker pull, Docker run, and Docker compose. Let's take a look at a demo to see how it works. All right, let's open up our demo script. I have prepared a demo script so that we can go very smoothly. So first one is the basics. So let me close it. So what we're going to do is that Docker pull. So to be able to run a container, you need to have a Docker image. So for SQL Server, we have Microsoft/MSSQL-server-Linux latest. This is the name of our Docker image that we're going to use today for SQL Server 2017. Let's run it. All right, so I already downloaded this image before this demo, so it was quick. Usually, downloading time would be like 20 seconds, and it's pretty fast. And then, once you have the image, next step is to run Docker. For SQL Server 2017, there are 4 important parameters that you need to specify. One is the port. So in this case, the default port is 1433. I'm going to map it as a 1431. So you can choose the port number as you wish. Next one is that it requires accepting a EULA and defining as a password. I'm just showing this password for demo purpose, but don't do this one in the real practice. And the third parameter is setting the SQL Server 2017 edition. For our demo, we are going to use developer. All right, that's all what you need. With just the one command, now, let me show you Docker PS. And our SQL Server 2017 running a container is up. So that is what you need to run SQL Server 2017 in Docker container. That's that simple. So to remove this container, you can just run docker rm remove -f and the container name, which is demo SQL Server. So that was pretty simple, right? And what we usually do is that we need to have an application and database run all together. So how we can do it really simply? That is Docker compose command. It's a utility of Docker, and you can define. Let me show you. The SQL Server and the web application all together in one file that is called the dockercompose.yml. So let's go through a little bit about this one. What it does is that you can define SQL Server 2017 container as one service. And likewise, what you saw in the Docker run, you can define ports and you can define the environment variables that SQL Server requires in the file. And you can also add your application, likewise a web application, which is pulling down the image from Eric S. Kang, which is my hub.docker.com account name, and the web app latest version. And this application depends on database, of course. So we define it as MS SQL. And a container name with a web app. And I'm going to map the port 3000, which was defined in the application, to 80 when this web app is running as a service. So let's quickly take a look at how it works. So once you have a docker compose.yml, what you need is docker compose up. That's it. All right. Within a few seconds, what it does is that Docker Compose creates a network so that the web application and our SQL Server 2017 can communicate and they bring up the database and application all together as a service in one command line execution. Let's quickly check if it is really running. So I go to my web page and run localhost. Because we map the application to localhost 80, port 80, here we go. So our application is running, and it's connecting to our database. In the previous demo, you have seen how easily you can bootstrap SQL Server 2017 in a Docker container, and how to run an application and database as a composition of service. For your own project, you'd want to build your own Docker images. For that, Dockerfile and 2 commands will do the job for you. So remember Dockerfile, Docker build, and Docker publish. Again, let's take a look at a demo to learn how. So to build a Docker image, you need a Dockerfile. Let's open up a sample Dockerfile. Here we go. Dockerfile always starts from a from command that defines your base Docker image. In this case, we recently released MS SQL Tools image that contains SQL command and BCP. So we published it to Microsoft/MS SQL Tools and latest. It'll be my baseline image, so my image will contain those tools that I'm going to use. Next, what you need to do is that you can do many different commands like installing more applications in your Docker image, or you can create a work directory. You can copy files, and so on. There are many commands that you can learn, but in this sample, I'm going to show you how to create a sample directory, and I will copy restore.sql, which contains my commonly used restore statements, and then so that I can just use it within my image. The last command is cmd that defines what is the executable command that you want to run when container boots up. All right, let's go back. So once you have the Docker file, the command that you should run is docker build dot means within the same directory, and you tag it as your final Docker image. In this case, Eric S. Kang, which is my Docker image name, the Docker hub name, and then image that I want to create, which is a demo image. Let's try and run. I copied it and paste it. Right, within a few seconds, the Docker engine builds a new image, and that's it. Once you log into your Docker hub or your private project repository or your own Docker registry instance that you are running by yourself, you can publish that so that you can use it by yourself or your team members, or even share your public image to community. So the command is also simple. Just say docker push and your new image name, which is Eric S. Kang / demo image latest. So let's run it. All right. So within a few seconds, it's published to your hub.docker.com. So let's go and check where it is. So as I mentioned, if you go to Docker hub.docker.com, let's scroll down. Here we go. So we just published our new image to our public repository. As I mentioned, if you are building your image for your project, then you would consider to publish it into a private repository. Hub.docker.com provides you a private repository, or you can use Azure Container Registry, which will be your project team's private repository. Great. So far, you have learned all the basics of running SQL Server 2017 in a container and building your own Docker images. Let's move into a more advanced but exciting subject, container platform. AKS, Azure Container Service, which is in public preview now, supports DCOS, Kubernetes, and so on. You have multiple choices for the container platform. AKS helps you easily set up a container platform in Azure with a few command executions and a cup of coffee. Once it is set up, it allows you to run containers at scale with ease. You can manage containers' health and resiliency automatically. Most importantly, you can easily work with a persistent storage. Please remember that containers are ephemeral. That means if you stop and kill a container, then database files in the container will be lost. So you need to store database files in a persistent storage. In the next demo, we'll use Kubernetes in AKS. Just remember two commands, kubectl apply and kubectl delete. Let's see the demo. In this demo, I'm going to show you first how easily you can create a container platform using Azure Container Service. I opened up my third demo script, which shows first creating an Azure group using adds CLI. Adds group create name is connect AKS, and the location is West US 2. This one creates a group that will have my the Kubernetes container platform resources in that. The second command that we need to run is adds AKS and create. So the group will be the connect AKS that we just created, and the connect cluster, which will be our new container platform's name, and number of agent. We will use 2 agents in our Kubernetes cluster container platform. Once it is executed, while waiting, what we can do is that we can run install CLI in local machine. And then once the setup is completed, you can run as AKS get credentials command so that you can pull down the configuration file from your container platform and save it in your local machine so that you can communicate with your cluster from your local machine. Let's run it. So I'm going to create a group first. Okay, here we go. So within a few seconds, it is created. Now let's create a container platform in Azure Container Service. This will take for a while, so we will switch to the container platform that we already created for this demo. Right? We are going to use the container platform that I have already prepared for this demo. So let's open up the deployment script to the container platform. As I mentioned in the slide, for database, persistent storage is very important. To provision a persistent storage, you can use persistent volume claim in Kubernetes spec. It is very simple. You can define the name of persistent volume claim in namespace, storage class name, which is default. I'm going to show you what default means in Azure Container Service. And then you just claim how much storage you need. Let's say 10 gigabytes for our use. Okay. And the command that I'm going to use is that kubectl get storage class. let's take a look at what Azure Container Service already provides for storage class. So as you see, the default is basically using Azure Disk. It is embedded service of Azure Container Service. If we claim persistent volume of 10 gigabytes, then Azure Container Service automatically provisions that disk for us. So it's very easy. Okay, let's go back to our script. As I mentioned, to deploy a resource into container platform, especially Kubernetes, you can use kubectl apply -f and then the definition file or spec file, which is in YML format. I'll let it run this one so that I can show you what we already have provisioned. So as you see, SQL PVC claim 1 is already provisioned. The storage is bound to a location of this PVC and then the unique name and capacity of 10 gigabytes. So it is ready and use. So now let's take a look at how we can deploy database into container platform. I have defined a configuration for that. Let's take a look at it together. So similar to a Docker Compose file we've seen, we define a type of controller which controls the resiliency and the scheduling and the health of the container, which is encapsulated in a pod, which is the concept of a container platform. So in this case, we are going to name it as MS SQL and expose it as a service MS SQL. And we are going to use the persistent volume that we just provisioned. Likewise, Docker run, we are going to use the MS SQL Server Linux. And port and environment variable that we have seen in the Docker run demo. And the volume that we are mounting is /var/opt/mssql. Under this, we store master databases and all the database files under here. So even though this container dies, the database files are persisted in our persistent volume. And because it is a database, we are going to make it running behind the firewall, and it is only exposed to the containers and pod within container platform only, which is defined by cluster IP. All right, let's take a look at how it runs. So I copied kubeapply -f SQL-stateful set.yml, which is our definition for SQL Server 2017 running a container platform. All right, do it again. All right, so by running that command, both MS SQL the service and the MS SQL stateful set controller are defined. In the back end, Kubernetes will pull down images and run that service. Let's do one more thing before we go. We want to run application along with the database together. So same thing. We define service web application and expose port 80. And this time, instead of running it as a cluster IP, which is available within the container platform network itself, we are going to make it as a load balancer so that we can have a public IP and that we can access the application. And this time, I'm going to use deployment type as a deployment controller. And the container name is web app. And I'm going to pull the same image that we demoed in the Docker Compose demo case. Okay. Let's run it. Okay, now it is configured. Let's run if those services are running in the AKS correctly. It's a kube control get services. All right, MS SQL, which is our SQL Server 2017 database, and the web app, which is our Node.js application, are running correctly. For web app, it's exposing external IP to this IP address. So I can copy it and go to web browser. And I can type enter. All right, our web application and database are running correctly in the container platform using exactly same image. So far, we have run all the tasks using command line and script only. Anything that you can run in a command line interface or with a script can be automated using Visual Studio Team Service. Let's take a look at the last demo. So let's take a look at the Visual Studio Team Service. I have created a build definition which is triggered by a source code check-in or source code change in the GitHub. What it does is that I'm opening up the definition of the build definition in VSTS. It's very simple. It gets the source and it runs a simple setup. And what it does is that it runs MS SQL unit test docker build and push script. As I mentioned, this script contains docker build and docker push commands. That is exactly the commands that we used in this demo. Again, anything that you can run in command line or script can be automated using Visual Studio Team Service. Also, Visual Studio Team Service has built-in templates for Docker and other container platform. So if you go to search Docker, then you can see Docker and Docker Compose, which is familiar to us already. If you want to use container platform, you can type in, let's say, Kubernetes. Here we go. There is a deploy to Kubernetes template. Either using the script that you have created during this demo, using Docker or Docker Compose template, or deploy to Kubernetes in Visual Studio Team Service, you can easily automate all those Docker operation using the SQL Server 2017 very easily and enable automated CI and CD. Today, you've learned the basics of running your application and the database in Docker container and container platform. For more information, please visit aka.ms SQL DevOps page or Channel 9. Thank you very much for watching this session.